Okay, so in this video, we're going to determine the exact values for angles that are less than 90 degrees. So, why do we even use exact values? Well, exact values allow us to give responses and answers that are much more accurate. When we have to round or approximate, we're not getting the most accurate value. So, whenever it is possible, we want to use exact values. And what do we even mean by that? Well, if we were to ask you to find the exact value of, let's say, sine equals 35 degrees. Well, if I plug this into my calculator, sine 35 degrees, I get a very long decimal, 0.57357, and it continues on forever. There's no repeating pattern. So it's very difficult for us to come up with an exact value for that. And we would just say that sine 35 is approximately equal to that. However, if I had, let's say, sine 30 degrees, well, if I plug that into my calculator, again, oh, look, I get 0.5. I can actually express that as a fraction, which is just 1/2. So sine 30 degrees gives me a concrete value. What about for cos 30 degrees? Well, cos 30, we get, again, a very long number, 8660254, and that continues on. Now, if it was possible to express cos 30 degrees as a fraction, why wouldn't we do that so that we could get more of an accurate measure? And that's what this lesson's all about. So now, looking back at our note here, it says that the angles that have exact values are called special acute angles. And they are 30 degrees, 45 degrees, and 60 degrees. So that means that if I wanted to find the value of, let's say, sine 30, or tan 60 degrees, or cosecant 45 degrees, because the angle is one of the special angles, that means that for each of these trigonometric functions, we can actually state the answer as an exact value, like 1/2 as a fraction, versus just rounding our number to a certain number of decimal places. So the key thing here to recognize is that for any trigonometric function, whether it's primary or the reciprocal, as long as the angle is 30, 45, and 60 degrees, we can state the value as an exact measure. So we're going to figure out exactly how to do that. Okay, so a lot of teachers in schools, what they'll do to help students memorize and learn the values of the special angles is they have you create the special right triangles. And if you notice in the first triangle that has the angles 30 and 60 degrees, they would ask you to use the concepts that you've learned in grade 10 using SOHCAHTOA, the ratios for solving right angle triangles, and solve the exact values of those angles. So for instances, if you wanted to find the exact value of sine 30 degrees, well, we know that sine is equal to the opposite side over the hypotenuse. So if we look at the special right triangle, the 1 would represent the opposite side and the 2 would represent the hypotenuse. So therefore sine 30 degrees would be equal to 1 over 2. Opposite is equal to 1 and the hypotenuse is 2. And if we look at our chart, sine 30 degrees is equal to 1/2. But I personally don't like this method. I don't like this method for a couple of reasons. One, students don't memorize and know how to create the right triangles appropriately. So when they're on their test or quiz and they're trying to solve through a problem, they either draw the triangles incorrectly, with the incorrect lengths on the opposite sides, with the corresponding angles, or it's just, one, it takes too much time to create them, and they tend to make a lot of errors along the way. So I personally do not like this method. I'm not going to teach this method. I'm going to teach you a much easier way to memorize the exact values. Okay, so the method that I use uses the unit circle in order to memorize the exact values. Now, in terms of the unit circle, we will be getting into this into a lot more detail as the unit progresses. But for now, all I want you to keep in mind is that the unit circle has a radius of 1. Okay, and the unit circle helps us determine the exact values of angles ranging from 0 degrees all the way to 360 degrees. And we know that when we measure an angle of 360 degrees, it actually creates a circle. Okay, so the unit circle helps us identify the exact values between 0 to 360 degrees. But in this video, in this tutorial, we're actually only concerned with quadrant 1 because we're dealing with exact values of angles that are less than 90 degrees. And angles that are less than 90 degrees would only fall in quadrant 1. Anything greater than 90 would fall in either quadrant 2, 3, or 4. So if we keep in mind that this unit circle here has a radius of 1, and that tells me that this point that is on the circle would have the coordinates of 1 and 0, because I know that the distance from the center of the circle to a point on the circle would be exactly 1, since it's the radius. And then right here, the point that's right on the y-axis and on the circle, well, that too is also, it also represents the radius. So the coordinates of that point would be 0 and 1. And I know that the angle that's made between the x-axis and the y-axis is 90 degrees because the two lines are perpendicular to one another. From previous years, recall that perpendicular lines make an angle of 90 degrees. So the next step that I would have you do is sketch in our special angles. Now our special angles are 30 degrees, so I'm going to approximate that that's 30, 45, and 60 degrees. Okay? Now, if we go back and rewind for a second. Now, if I were to take my calculator and plug in cos 0 degrees, I would actually get 1. And if I were to plug in sine 0 degrees, I would get 0. What I want you to pay attention to is that the coordinates of the points on the circle represent the exact values of that function. So let me write that down for you. The coordinates of the point that falls on the circle represent the exact values of the trig function. And it's very important to remember that the x-coordinate represents the exact value for the cos function, and the y-coordinate represents the exact value of the sine function. Okay, so I've recreated the unit circle here. So again, just to reiterate, we know that the x-coordinate represents the exact value for cos, and the y-coordinate represents the exact value for sine. So what I've done for each of the special angles for 30, 45, and 60, I have drawn brackets to represent the coordinates for each of those exact values. Now, we know that exact values will be a fraction, otherwise it would just be a whole number. So that's why I've drawn little dashes in between the brackets to represent the division sign for each fraction, so for each coordinate. So what I want you to start off by doing is to write in 2 for your denominator for each exact value. Then we're going to start with all the coses first, and we're going to start right at the top at 60 degrees. And you're going to write in 1 in the numerator and keep increasing up until you get to 3. Then you're going to shift over to the sine coordinates, And you're going to start back at 1 and work your way back up to 3. And then we're going to go and square root all of our numerators, okay? Now, if you notice, for 60 degrees, we have the the x-coordinate equivalent to 1/2, and the sine coordinate is equal to root 3 over 2. So what that means is, if I wanted to find the exact value of, let's say, sine 60 degrees, well, I know sine is represented by the y-coordinate. The y-coordinate is equal to root 3 over 2, so therefore the exact value is equal to root 3 over 2. If I wanted to find sine, actually let's do cos to change it up a bit. Cos 30 degrees, well, I know that cos is the x-coordinate, and at 30 degrees it would be root 3 over 2 as well. Now let's say we wanted to find tan 45 degrees. Well, we know that we could rewrite tan as sine 45 degrees over cos 45 degrees. And now I can just go back in and substitute the exact values for each. So sine 45 is equal to root 2 over 2 divided by cos 45 degrees, which is also root 2 over 2. And then I would get root 2 over 2. So once we simplify that, we would just get 1. So this is how we can use our special angles to find the exact values. So now let's try a couple examples here. It says determine the exact values for the following, tan 45 degrees. Well, before I even start this, what I would encourage you to do when you're working on a test or a quiz, instead of drawing out the entire unit circle, I just draw in the first quadrant, and then I know that I want to draw arrows to represent 30 degrees, 45 degrees, and 60 degrees. And then I'm going to draw in my coordinates. Well, I know that I'm going to start off at 1, and I know that all my denominators are 2. And then it's going to be 2 over 2, 3 over 2, then I start back at 1, 2 over 2, and then 3 over 2. And then I'm going to square root all my numerators. Okay, it takes a matter of 2 seconds. As you start working on this, you'll pick up the pace, and you'll find that this is much easier than drawing triangles every single time. So now for secant 30 degrees, well, we know that secant is equivalent to 1 over cos 30 degrees. So all I need to do is plug in my exact value for cos 30, which is root 3 over 2. So I would have 1 divided by root 3 over 2, and I would be left with 2 over root 3. However, in math, we never like to have a square root in the denominator. So what we're going to have to do is rationalize. I'm going to multiply both my numerator and denominator by root 3, and I would be left with 2 root 3 all over 3. And if I wanted to check my answer, well, what I would do is actually take, 1 divided by cos 30 degrees, and that gives me approximately 1.154. And if I take my final answer and multiply 2 times root 3 divided by 3, I also get approximately 1.154. And therefore I know that my solution is in fact correct. Well, I hope this video helps, and it definitely clarifies how to find the exact values of acute angles. Please do not forget to subscribe if you like this video, or leave any comments if you'd like any additional explanations. Look forward to posting my next video.